pleasant prices. Codeforces Round 384 Div2. There's again a question on DP on trees. Moving on to the problem statement. The problem statement says that we need to choose two nodes such that the subtree sum of node 1 plus subtree sum of node 2 is the maximum, and node 1 is not a ancestor of node 2 and node 2 is not a ancestor of node 1. This is the question in brief. Moving on to an example. This is the example given in the question. For this, we'll store three arrays: number of children, subtree sum, and maxim will define what this is. Number of children is simple. We can populate this via simple DFS. Subtree sum is also simple. We can populate this via simple DFS. MAXM is defined as the maximum sum subtree in the subtree, whereas subtree sum node is sum of all nodes in subtree. So let's see what MAXM node is. So MAXM, so yeah, first of all, subtree sum of 3, subtree sum of node 3 would be -1 plus 2 plus 6 plus 8, that is equal to 12. Whereas MAXM of 3 would not be 12, it would rather be 13, because for maximum of MAXM of 3, we'll consider this subtree to be the subtree with the maximum sum. Yeah, so once this is clear what MAXM is, the way we populate MAXM is check. The way we populate MAXM is, let's say we are at this node, initialize MAXM of node to be equal to subtree sum of node. So so it will be initialized to all this. The MAXM of node would be initialized to STS node. Now it may be possible that this that right that only the subtree corresponding to children of node might be considered in the might be a better option compared to the whole subtree. To handle that case, uh, yeah, to handle that case, we'll say that maximum of node is equal to maximum of node, comma maximum of child. This is how we handle. This is how we create the array maximum, MAXM. Now the final answer would be stored in the array DP, where let's say we are currently at node. These are its children, ch1 up to chn. Okay, so DP of node can be defined as, if we have more than two children, then we can always take the best subtree sum of best subtree from child 1 and best subtree from we can always take the best two children such that the best subtree of those children are the most optimal. What I mean to say is that we take the two maximum elements from maxim of all the children and take their sum. What this basically does is we are taking the two best things and taking their sum. Now, since these two nodes lie in different subtrees altogether, the problem of one being an ancestor of the other doesn't arise. So this is a case. This is there, but and also there can be a case when we are not taking most optimal subtree doesn't include node itself, right? So it would be either of it would be the maximum of all the children. So we need to find the answer of each child, and TP of node would be defined as a maximum of DP of node comma DP of child. Seeing the code, In DFS1 we calculate the subtree sum. In DFS2 we calculate the maxim array. In DFS1, in DFS2, and in DFS we calculate the DP array. And let's see the functions. DFS1 subtree sum number of children. DFS2 calculate the maximum array. In DFS find DP. So we are initializing DP of every node to be minus infinity. The reason why we are doing this is if finally from 1, if finally the answer for 1 dp1 is minus infinity, that means it is impossible to take two children which satisfy the take two subtrees which satisfy the conditions given. So when it is impossible, the case when it is impossible to get the answer is when all the nodes have degree less than equal to 2, which is basically a linear graph, linear tree. So in this case, uh, this is never satisfied, and all the dp of children values are initialized have been initialized to infinity. So this would also give us minus infinity. So this has been taken care of. Impossible case has been taken care of, and yeah, and the way we handle DFS is check if the number of children is greater than equal to 2. That corresponds to this condition, uh, and find the sum of the top two elements. And then for this condition, uh, do this.